Good evening, the viewers of NTV and my dear students who are watching this program. My teacher, this is your live class through which you will be able to study certain lessons, and of course you can, if you have any queries to ask, that also you can be settled through this show. Today my focus is to some questions based on 11th standard contents. You know, 11th standard examinations are fast approaching. Now, after a few weeks, we're going to have final examination. Then soon after that, we'll be getting into 12th. So, I need not have to say, all of you are in the serious preparations. And, you know, just the whole load of the contents are going to be there for the exam. So what you need to do is you should have a very, very specific planning. Don't waste your time and refrain from all sort of outside activities for the time being. I'm not against that, but for the time being, because you know it may affect your health, it may you know, spoil the days. Even losing a day will considerably affect your preparation level as well as your performance. So, with a dedicated approach and a proper planning, definitely you'll be able to grab as maximum as possible, and the coming days, whatever potential you're making use of towards your academic performance, definitely it's going to be a worth. So, take it in a serious way. So, before getting into the questions to practice with exams, let me tell you, remember, this is a live classroom and I'm Rajiv with you. And every Tuesday we are going to have physics sessions, and last week we had session for 10th grade. Now it's 11th, and next week we will have a 12th standard session as well. So accordingly we will be able to plan. And of course if you have any problems, numerical problems or anything to sort out, you can send us in the mail or you can call us and ask. In case if not possible to settle today, and we'll be able to discuss the same questions in the next class as well. So it's your show, it's your class, so make use of this. Obviously, so at the beginning, let me point out a few errors or mistakes that commonly you make while you go for the examinations or while you write the examinations. Okay, so this I'm mentioning now in order not to happen these in the examination. Whereas in the answer sheet, when you present your answers, remember there are certain things you have to be very much alert on or be careful about. Alright, the first point I want to tell you is about the conversions. That is like in a milli to micro or a micro to SI unit. So all physical quantities are to be expressed in the SI system of units. In the SI system of unit, to convert, you should have there are certain prefixes you must be familiar with. So most of you may be knowing, that is milli, micro, nano, pico, etc., etc. So now, the thing is, these kind of questions, when you answer, that is numerical problems when you go ahead with, the final answer should be written in the appropriate unit. So first is conversion, second is writing units. What all common errors you may make, that's what I'm telling you. Okay, wherever, sometimes some of you may be very much concerned about the units, so even if ratio of two quantities, if it is asked, there also you will try to write the unit, but ratio means no unit. Right, so the case of conversion, the case of writing proper units in the final answer, appropriate units. Okay, so when you read a question, the very first thing is you should try to analyze the question properly and try to write down the data given in the question. Then you figure out what concept it is related to, what kind of equations we'll have to use, sort it out. It will come automatically if you analyze the question for some time. So within that time you will approach, you will arrive at an equation and note down the equation and try to figure it out, and definitely you will be able to reach the answer. But be very clear, if the calculation part is a little complicated, it's better you just leave it for the time being, but don't forget to write the unit. Okay, last phase, when time permits, you can come back and do the calculations. Okay, if it is lengthy calculations, if it mental calculations and all, it can be done and it can be settled very fast. Another thing, after finishing your numerical problems, every numerical problem, after doing it, or every question in that matter, you should come back and check again. Before getting into the next question, you should recheck the question and find out where all you have answered, what all according to the question or as per the question, have you answered everything what is expected in the question. That's something which you are going to check. Maybe after the examination you will come to know, this part I could not attempt, I forgot, I didn't see. Right? So to avoid disappointment, always recheck before getting into the next question. What you have to recheck is whether you have attempted all the subsections of the same question. Second, whether the answers are written just the way the questions are asked in the question. Right? So that is something which you have to really look into. So I mentioned about the conversion, then proper units, appropriate units. Another thing is, while drawing diagrams, you have to be really careful about if it is vector diagram, the magnitude and direction of the vector should be clearly shown. Alright, the diagrams, whenever diagram plays a very important role in many of the answers in physics. So when you draw the diagram, don't take it as insignificant. The diagram, some of you draw the diagram in one corner, very small diagram. Right? So, that should not be the case. Draw big diagrams, and particularly, you use pencil and scale for drawing the diagrams. Okay, so diagram, because many questions you can see diagram based questions are there, and even some derivations you can see diagram based derivations are there. So if you follow from the diagrams, definitely you will reach the final point, final destination very fast. You see, when you read a question, you are it's like you are standing at a junction. You don't know in which direction you are going, you have to go. So you are reading the question and analyzing, and to find out what way you should proceed. So that point of time, that is reading the question and finding out the way in which you are going to go, that's a very crucial time, because if you take a wrong decision at that time, surely you may go to this way. Like, you are supposed to go in this way, but you will be walking to this way only. Meaning, you will not reach the destination even if you are, trying hard. So, the crucial point of time is the time you read the question. So, that time you don't be hasty, don't be in a hurry to finish off reading the question. So, do not arrive at a conclusion very fast. Don't take a decision very fast. Right? And you have to see, maybe there are some small twists in the question. It may not be exactly the same as what you have seen. So there are certain cases of that sort. So be very particular about reading the question carefully, and after analyzing the question, after finding out yes, this is the way, after confirming the way you have to go, okay, this is the way you have to go, then you can be fast. So in simply analyzing question, take time. Execution of the answer, be fast. Then you will do right. Hope it is clear. Okay. Another common mistake, let me tell you, that's the case where temperature, the quantity temperature comes. The temperature is expressed in degrees Celsius, Kelvin and all, or in absolute scale. If temperature is given in degrees Celsius, you have to add 273 to convert it into Kelvin. You know it. But in some questions you may see that it is not converted. Even if it is given in degrees Celsius, it is not converted to Kelvin. Specifically, let me tell you the cases which you do in 11th grade. In the case of efficiency, we have the equation. Efficiency is 1 minus T2 by T1. You must be remembering that. T2 is the temperature of the sink, T1 is the temperature of the source. So, and another equation is about coefficient of performance. There again, the equation when we use T1 minus T2, T2 divided by T1 minus T2. There again, we have equation in temperature, in terms of temperature. Then we have an equation for Q is equal to mc into T2 minus T1. Then another equation about linear expansivity, which is alpha is equal to L2 minus L1 divided by L1 into T2 minus T1. These kind of equations when we use, in some of the equations we see there is difference in temperature comes, T2 minus T1 or delta T. If that comes, remember there is no need for conversion. 1 degree Celsius change in, that is 1 degree Celsius change of temperature is equal to 1 Kelvin change in temperature. Change, if it is, do not convert or no need to convert it into Kelvin. Whereas, if it is, for example, temperature, the efficiency equation 1 minus T2 by T1. So, T2 divided by T1, there is no difference of temperature comes over there. T2 by T1, right? It's a ratio. So, there you must convert temperature into Kelvin. Okay, so that is something which we have to be very clear about in the conversion. So, by the way, since we are talking about conversion, let me ask you one question for you to think on and send us the answers as by SMS you can send. You can see, 3939 is our SMS number. I'll give you a small question for you to answer and send us. That is a simple question. How many micros are there in 1 milli? My question, how many micros are there in 1 milli? Learn conversion properly, then you will be able to answer this. It's a simple question. Once again, let me tell you how many micros are there in 1 milli. Find out the answer and send us the answers by the SMS. Alright? Okay. So, we are talking about the common mistakes or errors you may make in the examination. Conversion, writing of units, drawing diagrams, right? Forgetting about the subsections of different subsections of the same question. And even sometimes some of you are not bothered also in writing the question number. Say maybe 25th question you are answering, after which you are going to 26th question. So, after finishing the 25th question only you will come to know, okay, the next is a very easy question. I know the answer is I can answer it very fast. It's based on a diagram. So, what you do is you will close the pen, you will take the pencil, start drawing the diagram, but you will forget to put the question number. So, appropriate question number should be put. And again, one more thing is like, do not stick on to a particular question for a long time. That's another thing to remember, because definitely it will it will waste your time. The time available for you to answer the question cannot be extended. So, within that maximum possible you have to write in the answer sheet. That is the main task. So, maximum performance within that limited time, for which to be possible maximum you have to attempt. For that, if you are sticking on a particular question, how you will be able to do it? Right? And some of you may commonly you say last questions are descriptive type of questions. I could not complete it because of lack of time. They snatched the paper and I couldn't complete, so crying and all sort of disappointments there after you come out from the examination hall. That should not happen. What in case if you are finding difficult to complete, that is the common experience if you have, try to finish off the descriptive type questions first, but do not take long time. Maybe in 11th and 12th content, there is an approximate calculation, nearly 10 minutes, 9 to 10 minutes maximum you can take to answer a 5-mark, last 5-mark question, descriptive type question. So in that case, first at the beginning itself, if you are able to finish it off in the 3 5-mark questions if there are, right, around maximum half an hour you take, then you will be able to finish off your paper in time. And again, some 1 mark, 2 mark questions, if at all, if you want to think more, so try to finish off those questions which you know, which you can answer easily. Then you come back to the questions which you need to think. Okay, that's what I want to tell you. Then about the conversion of temperatures, I told you it's not like degree Celsius to Kelvin temperature conversion is not required whenever difference of temperature comes. Even linear expansivity also we have equation. Linear expansivity, what equation we have is alpha is equal to change in length divided by original length times rise in temperature. So here also rise in temperature comes. There if it is, sometimes you might have seen like the value of alpha is given in per Kelvin. But per Kelvin or per degree Celsius, same value, because the difference only, right? And so here no conversion required, all right? And even but how about the efficiency equation, 1 minus T2 by T1? Here you need to convert, right? And even the coefficient of performance of refrigerator, there also you have to convert. So you be very clear about what all cases you have to convert, what all cases you don't need to convert. So there, if you can make out clearly, then you will not make mistakes. And efficiency, what you will write as the unit? You can either say in fraction or you can write it as in percentage. Just multiply with 100 and write. Okay. So that's what I want to tell you. Now we will move on to some questions which last class we were discussing a few. So one of the questions, you can look at the question now. See some sample questions which are required for the examination. Again, I'm telling you, it is not specifically related to some specific contents. Rather, it is like we have a, randomly we have selected the question and we're going to work it out. So let's see, look at the question. This is from the chapter, the fluids, 11th standard, fluids, okay? The excess pressure inside a soap bubble of radius 6 mm is balanced by 2 mm column of oil of density 800 kg per meter cubed. Find the surface tension of the soap solution. So here, what you're going to make out is, now listen, I'll mention about that. That is, the excess pressure inside a soap bubble. What's the equation? What equation you studied for excess pressure? Excess pressure, you must remember this equation. 2 sigma by r is the equation you studied for the excess pressure inside a drop, where sigma is the surface tension of the liquid. Clear? Whereas if it is like, sometimes you might have studied this, or you might have used the letter S to represent surface tension, whatever it is. This is for a drop, but remember, this is for the case which is mentioned here is the case of a bubble. So bubble, what change you should make is, instead of 2 you have to use 4, 4s by r. So this is the excess pressure inside a soap bubble. Okay, so the question is, the excess pressure inside a soap bubble of radius 6 mm is balanced by 2 mm column of oil. A column of oil, what's the expression for pressure exerted by column of liquid? That is H rho G, where rho is the density of the liquid. So it's given this excess pressure is balanced by this much column of oil. Right? So what's the surface tension of the solution, of the soap solution? That's the question. You see, this is the question. Radius is given, but remember again, radius is given in millimeters. How many millimeters? 6 millimeters. You convert it into meter, multiplied by 10 to the power minus 3. The height, it's given 2 millimeter column of oil. This also is in millimeter, right? And density of oil also is given. It is 800. G is 9.8. You just substitute the values and calculate the value of S, which is the surface tension. S or sigma is the surface tension of the solution. Clear? So what is the question? You just think again. The excess pressure inside a soap bubble of radius 6 mm is balanced by a 2 mm column of oil of density 800 kg per meter cubed. Find the surface tension of the soap solution. I hope it is clear. Okay, so now you have a look at the next question. So this question comes in the chapter laws of motion, or in the beginning it comes. That is F is equal to ma and all. You can make use of that. So here, I hope you have read the question. A rifle bullet, go through the question, all of you. Remember, if it is, you can note down the data very fast along with me. We are solving the question. Okay, if in case any doubts, you can call. The rifle bullet passes through 2 planks in succession, and the average resistance of second is 50% more than that of the first. The initial velocity is 800 meter per second. Initial velocity of the bullet is 800 meter per second, and the bullet loses 160 meter per second in passing through each plank. Show that the thickness of the planks are in the ratio 27:14. Let us prove this. So have you read the question? A rifle bullet passes through 2 planks in succession, and the average resistance of the second is 50% more than that of the first. The initial velocity is 800 meter per second, and the bullet loses 160 meter per second in passing through each plank. Show that the thickness of the planks are in the ratio 27:14. Okay, now you listen to the board. See, there are 2 planks. Let's say the thickness x1 and x2. We have to prove that x1 is to x2 is equal to 27:14. It's clear. but it's given it is coming with a velocity 800 meter per second. And after every, that is in this plank, each plank, it loses, see, it has got an average resistance of succession, and average resistance of the second plank is 50% more than that of the first. That is what force it exerts. 50% more will be the force opposed by the second plank. Okay, initial velocity is 800 meter per second, and the bullet loses 160 meter per second and passing through each plank. Meaning, when it is coming through this, its velocity would be how much? 800 meter per second is the initial velocity. So it loses 160 meter per second in passing through each plank. That means this would become 800 minus 160. That means how much it is? 640. Correct? 640 meter per second is the velocity when it comes out of this plank. And again, one more 160 you have to subtract. Okay, so what comes out when it comes out of the second plank? So again, 640 minus 160. Right? So it should be how much? It should be, sorry, yes, 480. So 480 meter per second is the speed with which the bullet comes out of the second plank. Correct? So we are going to find out the ratio of the two planks. How to find it out? 800 to become 640. So we can find out how much is the acceleration. Rather it is the deceleration. Right? So how to find it out? In fact, when it is given the average resistance of the second is 50% more than the first. It means if this is F1, if we take it as F, then what will be F2, the average resistance offered by the second plank? It will be 50% more. That is F plus 50% of F. That is, we can say 150%, 50% it should be. Right? That means 1.5 times the original force. Since the force is reduced, here whatever be the force, now the force becomes 1.5 times the initial. So what else will become 1.5 times? Acceleration. Because we know F is equal to ma. So acceleration is what? Force by mass. So if the force is becoming 1.5 times, it is what is happening to acceleration as well. If I take acceleration in the first plank as a, what will be the acceleration in the second plank? 1.5 a. Alright, a 1.5 a. So we have the acceleration, we have the change in velocity. Then what you would be able to do is, we can find x1. See, we know the equation v squared is equal to u squared plus 2as. This is what we have seen in the first chapter, right? First unit. So v squared, see here we have 640 as the v, this is u, right? So what will be this s, you take it as x1. So x1 is equal to v squared minus u squared by 2a. I hope it is clear. X1 is equal to v squared minus u squared by 2a. How about x2? Again same thing, v squared minus u squared by 2a. Remember, this acceleration is how much? The first acceleration is a1, second acceleration is a2. Alright, this a1 is how much? You take a1 as a. a2 how much? a2 is 1.5a. Right, a1 is a, a2 is 1.5a. Now, what about this v? In this case, v is 640. I'll write the values here itself. 640 squared. Here the value is 800. Initial velocity is 800. Okay, this is 640, this is 800. Whereas over here, v is 480 and u is 640 squared. So substitute all the values here, then divide. When you divide, this a's will be cancelled. So clear? So x1, so I am writing this as equation 1, this is equation 2. Then make two equations and divide, you will get x1 by x2, that you will get as 27:14. So once again let me tell you, the bullet is coming with a speed of 800 meter per second, hitting the first plank, right? And it comes out losing 160 meter per second, so this is the velocity. And it comes to the second plank, again it loses 160 meter per second, but it's given the average resistance offered by the second plank is 50% more than that of the first. That means this is 1.5 more, 1.5 it becomes, 50% more means this, if it is this is f, this will be 1.5 f. Accordingly, the acceleration also will be different. Acceleration if it is a, this will be how much? 1.5 a. So use this equation. I hope it is clear. You have seen this. You use this equation v squared minus u squared by 2a and get an equation for x1. right? All the values I have written here itself in this equation. Similarly, x2 also, you find out the equation for x2. There, instead of acceleration, you substitute 1.5. A, calculate. That means divide 1 by 2. You will get a value 27:14. So it's a little lengthy question, but you have to think a bit, and you will have to calculate also. These all calculations are required. Okay, is it clear? Now move on to the next question. Look at the next question. See, the question is, a pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cubed in 15 minutes. If the tank is 4 meter above the ground and the efficiency of the pump is 30%, how much electric power is consumed by the pump? Okay, look at the question. I'll read out the question once again. A pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cubed in 15 minutes. If the tank is 40 meters above the ground and the efficiency of the pump is 30%, how much electric power is consumed by the pump? Electric power consumed by the pump, the actual electrical power. Okay, and what is given in the question is density of water. Okay, now I'll show you the answer to the question. You can listen to the word. See, ground floor of the building, there is a pump. Okay, it can pump water to fill a tank. So there is a tank here. The tank is at a height of 40 meters above the ground. Okay, we have to fill up the tank with a volume of, how much volume we have to fill is 30 meter cubed. Okay, 30 meter cubed is the volume of the tank. The tank is 40 meters above the ground. Efficiency of this pump is, there is a motor pump. Efficiency is how much? 30%. Question, how much electric power should be consumed by the pump? This pump, power of this pump is a question. Density of water is 1000 kilogram per meter cubed. Yes, can you make out how it is, how it can be done? Very first thing is think of the efficiency. Correct? Efficiency means how much is the output divided by input. It's clear. So let us write like that first. Efficiency is equal to output divided by input. Okay, when you say output by input, it can be output energy divided by input energy or output power divided by input power. Okay, so we say efficiency is 30%. It's given efficiency of the pump is 30%. So that means, let us first think of the power developed. Okay, so 30% we will write like this. 30% is equal to output is what? What for the output is used? To lift the water up. Lifting the water up means it is to gain potential energy. Work done to lift. What's the equation for work done to lift? It is what is nothing but the equation for potential energy. What it is? mgh. Work done to lift water. Lift anything is mgh. So the output power should be mgh by T. Correct? This is the output power divided by the input power. Let the input power be P. That's the question. That is, what's the power of the pump? That's the question. So let P be the input power. This is the output power. You know, it's given the process is being done in 15 minutes interval of time. So the question again, therefore P is equal to, this is 0.3 we can write, correct? So mgh divided by time into 0.3, right? But one thing is there, mass of water to be lifted up. What's the equation for mass? How do you find mass? Mass is volume into density. Volume multiplied by the density gives mass, right? Into g into h divided by time multiplied by 0.3. Is it clear? Have you seen this? The efficiency is 30%. That is 30 by 100 is equal to, this is the output energy. mgh is the work done to lift. That is a useful work we are getting. That is output. Divided by time is output power. Divided by, because we require input power of the pump. Right. So we can rearrange and get the value power is equal to, this I wrote it as 0.3. Right. mgh divided by 0.3 into T. Now listen what all quantity is given here? The volume. Okay, so volume is how much given here? The volume of water to be lifted up, to be filled, is 30 meter cubed. So the power of the pump is equal to, substitute all the values, 30 multiplied by density of water is 1000 multiplied by G, let me take it as 10 multiplied by H, at what height it is to be lifted up to a height of 40 meters, divided by time, it is lifted up in 15 minutes. 15 minutes, you have to convert minutes to second. 15 multiplied by 60, that is the time, again multiplied by 0.3 here. You see, all the values are given and you can substitute and calculate whatever it is, whatever is the answer, that many watts is the power. That's the calculation of the power of the pump. Well, if you understood the question, what was the question? A pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cubed in 15 minutes. If the tank is 40 meters above the ground and the efficiency of the pump is 30%, how much electric power is consumed by the pump? Okay, you read the question and you saw the answer. I hope it is clear. This is the way to solve it out in an at the easiest way. Clear? So move on to the next question. See, next question is again it's related to the Carnot's engine, which you studied in the chapter thermodynamics. In thermodynamics, you have seen efficiency of heat engine, right? Efficiency of heat engine, like the ideal heat engine is what is Carnot's engine, and we have seen the equation efficiency as what? 1 minus T2 by T1. This is the place where we are going to think of the conversion of the temperature from degree Celsius to Kelvin if it is required, right? Okay. So you read the question. A Carnot's reversible heat engine works between 600 Kelvin and 300 Kelvin. In each cycle of operations, the engine draws 1000 joules of energy from the source at 600 Kelvin. Source is at 600 Kelvin. Calculate the energy rejected to the sink at 300 Kelvin. Energy rejected to the sink at 300 Kelvin. So I'll show you the method. So what all values given here? The temperature of the source is given as 600 Kelvin. Temperature of the sink is given as 300 Kelvin. And the engine draws 1000 joules of energy from the source. That means Q1 is 1000 joules. Okay, what's the question? Calculate the energy rejected to the sink. Q2 is the question. Then what else you got to find? What will be the external work done? Also we got to find out the efficiency of the heat engine. Okay, these are the quantities to determine. Okay, so energy rejected to the sink at 300. How do you find this one? You know, two equations of efficiency. One is 1 minus Q2 by Q1 and the other equation is 1 minus T2 by T1 in terms of temperature. So what else we can write therefore? Q2 by Q1 is equal to T2 by T1. Right. So now look at this equation here. Q2 only is unknown. That's the question here. Right. Q1 we have 1000, T2 we have 300, T1 we have 600. Just substitute and find out the value of Q2. Is it clear? How about external work done? What's the equation for external work done? External work done is nothing but Q1 minus Q2. See, here we are getting Q2 as how much? Q1 into Q1 is 1000 multiplied by T2 by T1. T2 is 300, T1 is 600. So how much we get? 500 joules. Q2 is 500 joules. So what will be Q1 minus Q2? 1000 minus 500, which is 500 joules. So second answer also we have work done. Then efficiency. Efficiency, one of these equations we use. Everything we have now. So just efficiency is equal to what? 1 minus 300 by 600. That means half, 1 by 2 or 0.5. In percentage when you write, it is just 50%. Okay, see, this is how we calculate the three quantities. Energy rejected to the sink, external work done by the engine, and efficiency of the engine. Okay, is it clear? So now this is a question where we are going to convert. If it was given in degree Celsius, it would have been converted into Kelvin. But here in this question already it's given in Kelvin. Right, some more questions we will discuss, but we will be going for a short break. After break again we'll come back. But before that, let me tell you once again one small question I had given you at the beginning. That is, how many millis make a, how many micros make a milli? how many micros will make 1 milli. Okay, so find it out and you can get back to us. We will have a short break now. Stay tuned.